Hi everyone. It's English today, right?
It is.
And very welcome to this lunch seminar today. I'm just here to remind you that there is a series of lunch seminars, so don't miss out the whole program because it's a lot of exciting and interesting lectures that will come every Wednesday, almost, to talk. And I also need to inform you that this lecture is being filmed. And you can also watch the lectures afterwards. It's all on the library website. So please take a look if you missed something interesting. By that, I leave the word to our speakers today. And we actually have 4 of them. So I will not introduce them myself. They can introduce them. Yes. Thank you for coming.
Thank you so much.
And also, a last thing, if you have questions, we're very happy that you ask them at the end, since, again, it's being filmed and I have to run around with this mic to give it to you. Okay, thanks.
Hello, everyone. My name is Emma, and together with Rosana, I work at Fiber and Polymer Technology here at KTH. With me today, I have 2 of my colleagues and partners in the project, Sebastian and Jonas, and we will all be presenting from different perspectives within this project. Today we're here to share with you a success story. This is a story about how academia, research institute, and a company work together to find solutions for new materials for a very specific product. First, however, I would like to put it in a larger perspective. If we talk about plastics, which is a very hot topic right now in the society, we need to look at the volumes that are produced in the world. And as you can see, it's about 350 million tons of plastics produced yearly in the world. A lot of discussions are ongoing about fossil-based materials. These plastics, these 350 million tons, are fossil-based. But if we put it in the perspective of the oil used for the production of these, it's only about 5%. Most of the oil is actually still going to transport and energy and heating. So why are these volumes growing constantly, the volumes of plastics? First of all, there is a big development on the product side. We have new applications coming all the time, new solutions. It's an increasing consumption within different sectors, and I will show you also the numbers on the different sectors, how much plastics we're using right now. But the good part of this is also that the waste management of plastic materials is increasing all over the world as well. So the new solutions for how to use the materials, but also how to take care of them at the end of life is increasing. If we look at the market, the largest proportion of plastics is still used for packaging. But different sectors are growing at the moment, specifically in car industry and also within electronic devices. That's a fastly growing sector. But as you can see, it's quite a dispersion in how much material is used for the different sectors. There is also an ongoing discussion that we need to remove the fossil-based materials and go further into the bioeconomy and find solutions with the bio-based materials. But as you can see, at the moment, the capability to produce the bio-based materials is not really matching up the volumes that are needed in the society. And these are the recent numbers from 2018, where it's only about 1% of the material is bio-based at the moment. And you can see the different types of materials as well. It's both bio-based and biodegradable materials that are collected here. So, our group, our research group, has been working with finding solutions for sustainable materials for a very long time. Mainly, we have focused on recycling, how to recycle the conventional materials that are on the market right now, but also to find bio-based alternatives and also how to combine the two, the fossil-based and bio-based alternatives, to create more sustainable materials. And in 2017, we had a pleasure to be contacted by a company that had a great vision, but a very challenging task that they wanted to fulfill. And I will leave the mic to Jonas to tell about the company.
Thank you, Emma. Hi everyone, my name is Jonas Marking and I'm product manager at a company called HL Display. We recently launched a new product range which we call HL Sustainable Choice, and this range is developed in cooperation with KTH, Emma's team, and Rosana, and also in cooperation with IVL, Sebastian. They will tell you more about the work they did, but my objective here is to give you the context and why this is important for us as a company. And I need to give you a few words first about HL as a company. So if we move to the next slide, please say hello to Harry Lundvall. He's the founder of HL Display. He founded the company in the 1950s, and he's from Sweden. And during this period, there was a great transition in the retail world. Before, you had shopped your groceries over a counter, but now we started to see supermarkets where you actually went into the warehouse to pick the groceries yourself. And what Harry discovered was that the price communication was not very clear, so he went back to his home, went down in a basement, and came out with a new product, which we call a data strip, which is basically a profile you put on the shelf edge, and it's a pocket with a transparent front, and you put a price label in it. It's a very simple product. I'm sure you've seen it. You haven't paid attention probably, but this product you can see in any store all over the world, and it was the invention of Harry Lundvall. So that's something to be proud of as a Swede. Today, we still produce these data strips, of course, and that's why I'm here. And can any one of you guess how many meters we produce annually? It's a very difficult question, but any guesses? Yes, please.
I'm feeling daring, but about 2 kilometers.
2 kilometers. Any other guess? Is it much? More? More? Much more. We actually make 40 million meters each year. And that's 1 lap around the Earth, a little bit more. Every year, our factory in Sundsvall is producing 40 million meters, quite a lot. And that's why this is important for us, because today these profiles are mostly made in PVC, which is a great material for the application. But over the years, we have also added other products to our assortment. So what started as a fairly modest company now is a big industrial player, and the industry has become quite big. The annual turnover is 150 million crowns. We operate in about 50 markets. We have 1,000 employees, and we operate 4 factories. One in Sundsvall, another one in Poland, one in China, and we also have a factory in the UK. So what Harry Lundvall started has become something truly big. So I think this is a great story of entrepreneurship. Just to give you a hint of other products we are doing as well. As I mentioned, we had the price communication, the shelf edge profiles you can find anywhere, and then we have a lot of products that help you keep a tidy shelf. We have the dividers to make sure that the products are standing in a neat line, and then we have different types of front feeding machines. So in essence, what we're selling to our customers are solutions that will help them increase the sales with clear communication and having a tidy shelf, and also to reduce labor cost by having these automatic systems. So that's what we do. We are proud to be in almost 300,000 stores around the globe, mostly in Europe, but a lot in Asia also. We have all major retailers as our customers. And this is where the interesting part starts, because nowadays all major retailers have sustainability on top of the agenda. This was not the case 5 years ago, but that's the case now. We actually started our sustainability work in our factories to make sure that our operations were run in a sustainable way. We started that work many years ago because we thought it was the right thing to do, not necessarily having such a big effect on sales. But now we can see that sustainability has a crucial effect to our sales. We can clearly see that being able to offer products that are more sustainable than competition will give us a competitive advantage. That's very clear. Also, there's another point to it. I had a meeting some time ago with IKEA, which is one of our big customers, and they said that, yeah, we are actually quite impressed that you are contacting us to tell us about your sustainability work, because usually IKEA has to go to the suppliers, forcing them to offer them more sustainable solutions. But we actually came to IKEA, so that was good for us. But then he added, but honestly speaking, a few years down the road, this will be a necessity. If you want to do business with us, your products need to be more sustainable. So the context for us is, today we are making our products more sustainable to gain a competitive advantage, but in the long run, it's clearly a question about survival in the market for us, because the pressure is so hard for our customers. Let's skip that one. So when we started to make our products, when we decided that we wanted our products to have a less big footprint on the environment, we also understood that we can't do this ourselves. We need partners with expert competence that we don't have in-house. So first, what we wanted to learn was, during the production process and life cycle of the product, where does the negative impact on the environment occur? Just to make sure that we were targeting the right parts in the process. The second thing we needed was numbers. We needed to measure, to understand the impact, so we can compare different alternatives, again, to make sure that we did the right thing, and also to be able to track the results over time. So for that, we took the help of IVL, and they made a life cycle assessment for us, and we started with the data strip, because that's the product that made most sense starting with. And then we also understood that we need to explore new materials. We need to replace PVC, or we need to replace virgin fossil-based materials, we say. And for that, we took the help of Rosana and Emma at KTH to find more sustainable materials. And that's not so easy. You can't just replace one plastic with another one, because we have a big factory in Sundsvall with 28 production lines, and we can't replace them all. So the plastic needs to work in the current production process, and then, of course, the quality of the end product needs to be equally good, because there's no point producing in a bioplastic, let's say, if the product breaks within a few days, because then you need to produce more, so that's not sustainable. So quite challenging demands on that, and we will hear more about it. But the result for us, it's been very successful. We were able to launch what we call Sustainable Choice, a range of products with a better sustainability profile. So customers can still buy and still do buy regular profiles in PVC, but they have the option to buy a product with a better profile. And our work now is we started with the data strips, but we are working on many other products also. For example, injection molding products. That's a new product we're starting up now, which is really interesting. And the goal is to be able to offer a sustainable choice for a third of our assortment by the year 2020. And that's it for me. Thank you. Sebastian.
Thanks a lot, Jonas. And this is where we come in. Sebastian Welling. I'm working at IVL, Swedish Environmental Research Institute, and we've been working with the LCA, the Life Cycle Assessment. But before I start telling you more about our journey, and that has been extremely inspiring and learning process for us as well to collaborate together with KTH and HL Display in this process, I would like to ask you, who knows what LCA, Life Cycle Assessment, is and stands for? Please raise your hand. Good. So maybe half of you. So this slide is not completely obsolete, so I will quickly go into it. So life cycle assessment, this is basically what I'm working with most of my time, is we look at products and also services, but in this case a product. So we look at this data strip. And if you see this data strip and we talk about sustainability, complex production technologies, how do we measure that? How do we quantify that? And this is where life cycle assessment comes in. So we basically look, okay, we have this data strip. There's some plastic granulate, there are processes, there's energy involved, we might use it at some point. At some point the customers will send it back or throw it away, will be incinerated or will be in a landfill. So what we basically do in life cycle assessment, and what you see on the picture behind us, is we look at the complete life cycle and look at all the streams, material streams, energy streams, and kind of put it together to be able to make a comprehensive analysis of the environmental impacts of this data strip or product. Quick LCA crash course, everybody understand that? I see thumbs up, great, so we can continue there. So this is where we started. We did a life cycle assessment for HL Display's data strips. And here I'll tell you something about the goal and scope, because whenever you look up LCA, you will always find different stages according to an ISO standard. And the first one is you need to define what's actually the goal of your study. And Jonas already told us they wanted to improve the sustainability of their products. And they're using different raw materials. PVC is the one being used the most, but there are also other raw materials. So what we did in this study is we wanted to compare different raw materials on the one hand. So what you see in the table there on the left-hand side, we looked at PVC, ABS, but we also looked at recycled ABS and recycled PVC to compare the environmental impact of these different raw materials. And what we usually do whenever you talk to an LCA person is we want to understand the process, the whole product system. So on the right-hand side, you see this flow chart, the different processes. I won't go into detail to all the different production techniques, but in general, as you saw before, you have a raw material, you send it to a producer, in this case HL Display of this product. You have some sort of production with energy involved, materials, and then you send it to your customers. You use it, and well, after the use, something is also happening, the end of life. And there in this case, actually, you see these three options. We looked at recycling, we looked at landfill, and we also looked at incineration, because all of them might have different impacts on the environment. And since we always want to work with specific cases, we specified which countries and which markets we looked upon. So we actually did the study for Sweden and also for France to have specific figures for those markets. So this is basically the goal and scope of our study. And in order to be able to compare the different results, we didn't compare this data strip with the other one because it's different types, but we compared the same type of data strip and the same amount. So in this case, we compared 20 meters. So 1 kilogram of DBR39, which is the name of the product. So that's what we did. So what have we learned? Well, let me show some results. And here you see 4 bars presenting the impact on climate change for data strips from different materials. On the left-hand side, we have the PVC, followed by the PVC recycled, and on the right-hand side, the ABS and the ABS recycled option. For the end-of-life scenario, incineration in Sweden. So we looked on the Swedish market and incineration, which is currently one of the most maybe applied settings in the end-of-life management as a base scenario. And here you see, well, yeah, they're kind of the same, but maybe not. So you see PVC is on a lower level than ABS, and you see also that the recycled ones are lower than the virgin materials. Which will make sense because you avoid producing new virgin material. If we look a bit more into detail into these results, and don't worry, I won't go into all figures and details today, but please feel free to come back to us if you have more questions. We also looked, of course, what contributes to this environmental impact. Because, I mean, this is a figure, 5 kilogram of carbon dioxide equivalents. What does it say? Well, it's a measure of how much you impact, actually, climate change through the production of 1 kilogram of this data strip. And here we actually see that, as we said before, the raw materials and end-of-life management are the major contributors, so-called hotspots. So this is actually also one of the good findings of the story is we need to focus on finding sustainable raw materials that can lower the environmental impact, but we also need to work with the end-of-life management because we see there is quite a lot of impact there. And also if we look at the ABS, it's similar figures there. But we see it differs a bit. So for the ABS, for example, we have higher impact from the raw material production, but still the end of life is a significant part. So this is something what I think is extremely interesting with LCA, that you can analyze and get quantitative information, as Jonas said before, to help improve your product. Well, we talk about sustainability. Here I just talked about impact on climate change. What did we learn on the other side? Well, we also looked on the acidification potential. Because, I mean, we have a lot of focus nowadays on climate change, but different materials might perform differently in different environmental impact categories. And here we actually see, well, the difference within acidification impacts is even higher. But if you look on eutrophication potential, we get the same results. But this does not need to be all the time the same ratio and the same kind of outcome, but it's important to look at the different results. So we made this for different impact indicators and different energy and different resource indicators as well. What else did we look at? The different end-of-life scenarios and the different markets. And here's a little overview of the best and worst case scenario. So the worst case scenario was the ABS on the French market with the incineration. And the best scenario there we have with the DBR39 PVC recycled on the Swedish market, where we also recycle the product afterwards. So on the very top, you see actually that there's quite a huge difference between the best and worst case. There's quite a big room for you to modify and improve your products. Not only by exchanging raw materials, but also working with the whole value chain and life cycle. Summarizing this, what we also looked upon is that now we compared ABS, PVC, both virgin and recycled. And it has been truly interesting to work together with KTH and with HL Display, because it's great to see that actually what you do, your results, will be implemented right away, and you see actually in change that they push certain materials, certain aspects for end-of-life management further. But it also is one signal actually that we saw from the different raw materials is that we need to look at this further. So we need to find maybe other raw materials, not only to lower our dependency on fossil fuels, but also to look, are there other materials that could work for the product properties, but also have a lower environmental impact. And this is actually a continuation of the study we did and currently are doing together with Rosana, which will tell you more about how actually bio-based polymers can come in and also substitute fossil material in this space. And I think with that I will leave on to Rosana.
Thank you, Sebastian, for the intro, and all my colleagues. And I'm Rosana Moriana. I'm working in the FPT department here at KTH. And for me, it was a really amazing journey to be together, all of us, in this project. And now I'm going to explain you how we did it reality. Because I think the scope of the things that Jonas from HS wanted, it was really ambitious. So we tried to concretize something feasible for us from an academy, what we can say, what we can do for the industry. And for me, I think the most nice thing, it has been like being in contact with Jonas and being in contact also with the Sundsvall factory, with the people there, because they are actually the people that knows about the processing and knows what we need, what we want to replace. So here is a bit the summary of how the project was developed. And we thought the aim should be like to design profiles from environmentally friendly polymers. So this was like the big topic, try to find something more green, more environmentally friendly, that could act as an alternative in front of conventional plastics that nowadays they are using to produce this data strip. And this was like, we should know that the conventional materials that we were looking for to replace was the PVC and the ABS. So the environmental advantages that we look for were these ones that we can see here. So we wanted something competitive, what they are nowadays doing, but also we wanted to look for something more environmentally friendly, as I told. So we wanted to increase the degradability of the material, but increase the degradability at the end of the life of the material. at the end of the life of the product. And with that, we thought it could be nice, because with that we could achieve some reduction and accumulation in waste forms, in the landfills, and also in the sea. And we could generate less pollution and less energy. And we wanted to find something independent of the petrochemical origin, so the idea was try to find some material, some alternative for the fossil-based materials. How to achieve this goal? So this is, as summarized, we were in charge to identify commercially available polymeric materials with low environmental impact that could be used as alternative to the conventional ones. And here we have some keywords that we should consider. First one, the thing that we look for is low environmental impact. And if you start to look for that in the web and try to find suppliers, it's quite crazy, because you can find all these amazing definitions: biopolymer, renewable resource, biodegradable, bioplastic, green polymer, bio-based material, compostable, water-soluble, non-toxic, and so on. And the truth is that sometimes the suppliers are telling these things without really understanding what that means. So when I started to look for that, I was in a shock, because I actually need kind of call the suppliers to understand what they're really meaning with these words. So this was the first drawback that I found to find suppliers. And then I will tell more about the history, how it ends, but this is only to put you in context. The next keyword that I think is really important is, as Emma said, we have to find commercial available materials, because if we want to really find something alternative to produce these kilometers and kilometers of data sheet, we really need to find something that is already being produced in high quantities. So this is the other two things that we were really discussing with HL and with EVL, that we really need materials with low environmental impact, but also available, and we need to know and to be sure that they can provide us quantities, enough quantities to be considered as an alternative. And of course, we have to speak about prices, because this is a company, so they have to have some earning. And the next keywords that I would like to point out from this sentence is alternative to the conventional ones. So we want something competitive, maybe not at the same level, but competitive enough to have a good quality product. So what we are looking for is a material environmentally friendly, with low environmental impact, available in quantities, and reasonable in prices, and also a material that could be used in the, as Jonas said, in the machines that they have nowadays, in the extrusion machines. So we need some materials that are covering from the beginning some operational criteria to use the machines that we have in the factory. And also we need a material competitive, so with some final properties to be used in the supermarkets. And of course, we want to have an extra value, so then we need an end-of-life management of these products. And for this reason, we also need EVL to be sure what we are doing is better from a sustainable point of view. So this is more than results, I think, is the summarize of how the project was developed, what we did, and how we interact. So I think it's a really nice example how institute, academia, and industry can go together and make a successful history that I think it was really, really nice to cooperate, and it was easy, the communication. So I think this is the best for the project. The communication was easy and was kind of, for me, it was an amazing trip and journey to cover with all of them. So let's go. So the first objective was to identify a list of potential commercial bio-based and environmentally friendly materials. As I told you, when I started to look for an internet, it was kind of crazy, because all the people say that the material were really the best, and also in terms of sustainability, really sustainable. But then, when you really start to see the materials, like, okay, I want high quality, this supplier has to have some quantities and has to be somehow trustful, I only find 25 different suppliers around the world that really were offering bio-based solutions, bio-based polymeric materials. And of course, every company was offering two different materials. So we could start saying for this reason, we have this 45 big number on the top, because I started with 45 materials to consider, and with 45 data sheets to read and to try to understand. And when we arrived to that, this was like the part of KTH, we call HL display in Sundsvall, the people that is in the factory, and we said, okay, now we need to identify the technical requirements, what you want from this material, what you really need to process the material. And they did a really nice list. They are really professional, so they did a really nice list with different physicochemical properties that they need for the material, and also based on the criteria that they have based in other materials. So with this technical requirement that I obtained from HL and the data sheet of the 45 materials, I did a first selection, and we selected 10 materials from that. After of that, that is where to contact the suppliers. We wanted to be sure that it was possible to have enough quantities, and we wanted to know the prices, and we wanted to have some kilograms to start to process these materials. So it was quite surprising to see that I only find these 45 materials, bio-based, and from that, not all were already available. So a lot of bio-based materials that they are offering or they are announcing in internet, they are in the kind of experimental phase. So they were not available, they were not ready to sell us in tons as we required. So from these calls, we discharged 3 materials directly because it was really difficult for us to trust them or to find materials with big volumes as we needed. And then we did a classification, and from these 7, we chose 3. These 3 materials that we chose were processed in Sundsvall by HL, and it was really amazing to see that all the materials were able to be processed in good shape. So I think this is what was working well, that we really understood the data sheet, and we really understood, the HL really knew what they wanted, so then it was easy to go to the suppliers and ask for the material and process it. So the different samples were prepared from HL, and then, together with them, we tried to see if the properties that these samples had were enough to consider these materials competitive or alternatives to PVC and ABS. So we did a lot of experiments, actually. Thermomechanical properties were tested, and also some rheological properties were tested. We did it in both places, KTH and HL, and we compared these materials, these 3 materials, with the conventional plastics. And we saw that they were quite competitive in terms of properties, and we selected the 2 best materials to go on. And now with these 2 materials, what we also wanted to prove is they are bio-based materials. So it's logic to think that maybe they are biodegradable or degradable during the degradable, so maybe they cannot offer enough resistance. So we wanted also to be sure that these materials were able to resist in the supermarket. So the next test that we did was to submit our materials to etching tests to ensure the resistance of the materials in different environmental conditions. We did different tests of compostability, water absorption, and thermal degradation, and we compared with the conventional plastics. And if it's true, this is something that all the people more or less know, and the bio-based materials are less resistant in front of environmental agents, but we consider and we show that these materials were enough resistant to be applied for this product specifically. So this was the role of KTH, and then IVL will enter, assessing the life cycle analysis of these two materials that are nowadays being used. And HL did the first prototypes of this datasheet that are already in the supermarket. And this is the end. And here is the contact information of all of us. So, thank you very much for your attention.
So now, are there any questions from the audience? Hands up. Yes.
Yes, it's a question for IVL. Do you already have the information on the life cycle assessment of the new materials?
I was expecting that question. Yes, we have come quite far with the results. Step in here, I can go in between. And as usual, you want to have as specific data as possible on all these. So we have some preliminary results already, which indicate that the bio-based material have a lower environmental impact on climate change, but we don't have the finite results yet. But the first results look actually quite promising and quite interesting. But we're waiting for some single last specific data to get the final results of that study.
Okay, thank you.
Hi. I wonder, cost-wise, what is the level of this compared to ordinary plastic?
The material is 3 to 4 times as expensive as the regular material we use, and also the production speed is slower in the factory. So the price we're selling to the customer is between 2 times and 3 times the price of the regular plastic. But then that sounds quite a lot, but you have to remember also that the cost in crowns for a data strip like this is not so much in the budget of running a store. So the cost in crowns, even if you have a steep price increase in percentage, the total cost is not so big for the store. And also I would say that in some cases this is an issue, because the way our customers buy, for example in Russia, they have e-tenders. You have to fill in your price on the internet in a column, and they don't ask if it's bio-based or not. So then it's not an option to fill in, a 3 times higher price and then trying to add somewhere that it's bio-based. It's not going to work. But we have customers who are looking beyond that, seeing that yes, we have to move away from our dependency on fossil-based fuels. So we need to do something, and we always need pioneers to pave the way. And the cost in crowns is not very high. So yeah.
Can I ask one more?
Yeah, take another first. Go ahead, Tom.
Thank you very much for sharing your success story. I was wondering, how long was this whole project from start until where you are today?
Since I have the mic, maybe I could start with saying that we started with the life cycle assessment, and that was started I think in May 2017, so 2 years ago almost. Yeah, and then
we actually started in parallel. IVL and KTH started to work in parallel, and we had a lot of discussions on exactly how to conduct this project so that we got the most reasonable results from it. And yes, we started in 2017 during the spring, and we were done 2018 late summer. But now we have a new project.
Anyone having another question? Then you can take your seat.
Well, you did a really great process here, and thank you for sharing your results. This was for displays, but for my company, I work with retail, and we do a lot of plastic hangers that I would like to replace. And I wonder if this results can be used for hangers as well, or do we have to start all over, so to speak?
You and me. Okay.
I think the most interesting of the project was, from my side, or our side, was to try to find these suppliers that they are really offering these bio-based materials. And it was not so easy, and not all are so good as they say. So this was actually, I think maybe 3 months of the project. So I think this part, we could escape it if you have the info already. But then all the other parts related with the quality and the processing, I think you need to start. Yeah.
So these products are using a technique called extrusion, and that's very different from making hangers. For hangers is injection molding, so you have a mold and you push in the plastic and then you take the mold apart. And so it's very different. And we have a plant in, as I mentioned, in Gliwice in Poland, where we are making injection molded products also. And we have just started up that project to try to replace that. Then we use lots of different types of plastics, a lot of PET actually. But we're looking into how we can replace those materials with both recycled materials, but also with new bio-based materials. And then we see it's quite a challenge because just the design of the tools impacts what type of material you can use. So it's a little bit trial and first doing the theoretical work, understanding the properties we need for the material, and then it's actually a trial and error to try it out in a machine, and how skilled the operator is plays a huge impact when it comes to injection molding. So that's, but I'm sure we can help you with hangers.
I would like to add one thing as well on the LCA part of like the results, because it's often in the discussion, in the popular discussion, okay, we know that paper bags are better than plastic bags, so you just have this like black and white view on it. ABS is better than PVC. Can we say it in all the situations? And I would say you need to be cautious. I mean, reality is complex, and as Jonas said, bio-based materials, for example, slower speed in production, so maybe more energy used for the production as well. It's different, it's difficult, so you would actually need to look on the different materials, transports, and all the processes involved. So just a word of caution. Don't take this as this is the honest and the true answer for all plastics all over the world. This is for our situation, LCA display, and of course you can look on different raw materials. But the whole product, it's complex, and I used to describe LCA as a tool to handle the complexity, but not to kind of like forget about the complexity. Just as an add-on.
And of course, now I have to add something. I'm really happy that you brought it up. That is a misconception a lot of times, that if you have a successful story on one product, then you can use the same material, for example. And plastics is a very complex material in itself. There are so many variations, and exactly as Jonas is pointing out, the materials that can be used for extrusion cannot be used for injection molding. So you kind of have to start over. You have to find new suppliers, new materials, new grades of materials, and trial and error is, unfortunately, the only way to go.
Can I add a last thing?
You have 1 more minute.
Yes, that's all I need. I also want to add that you have to have kind of a dynamic approach when you look on this, because original PVC been in production since the 1920s, something like that. And if we look at the bio-based plastics that we're using today, it's not on big scale, and the bioplastic we're using, for example, in these are made partly in Thailand by sugarcane, and then the energy mix they're using there is not maybe the best, and then we're shipping it to different parts of the world, ending up in the factory in Sundsvall. If we could make this plastic in Sweden, which we think we will quite soon, then we could use renewable energy, and we could use maybe corn husks from the wood industry, and then the LCA would look completely different. So the LCA gives us an honest result on what is the impact today, but we also have to look a little bit beyond that when it comes to these new materials. And we have to have a vision, being a little bit bold, making sure that we're taking steps towards something that we can live with, which is a fossil-free future.
Well, that's a nice ending, because the time is unfortunately up. But many, many thanks for you being here. And I don't know if there has been a life cycle analysis for these, but we hope they are sustainable. So thank you very much for this. Do you want to take one more?
Thank you.
Thank you for being here.
Thank you.
Thank you.